Now that we know the unit circle in degrees and radians, and we all know all of this already because we've seen it one whole time, or actually two whole times, so we should know it by now. I know this, I've watched like 2 NBA games, therefore I'm ready to play in the NBA. Isn't that how it works? You just need to watch it for a little while, and then you're ready. I don't know why we understand that so well about sports, but we don't understand that about math. Students like, well, I went to a lecture. Why am I not succeeding in this class? Why am I not acing this test? Like, well, you went to a lecture. Give yourself a break. One of the reasons that we want radians is that radians are a non-arbitrary way of measuring angles. So let's non-arbitrarily measure our angles. Here we have the unit circle going around once, shown as a unit circle. Here we have all these angles going around from left to right. This is where we are headed with this radian business. This is where we are headed with this radian business. We want to take these functions, sine and cosine in particular, and we want to start using them as models for periodic phenomena. We want a function that goes up and down and just repeats that process. We want functions for sound waves. We want functions that describe radio waves. We want functions that describe the waves. So I've lined up our iconic angles from 0 to 360, 30, 45s, and 60s using the colors that I normally use. And what we want to see is the 4 quadrants, but in particular, we want to see this pi in the middle. And we want to see the 30-degree angles close to the pi. So here at 150 is 5 pi over 6. And here at 210 is 7 pi over 6. The places that these 30-degree angles show up are closest to the x-axis. The x-axis being represented by pi, 0 and 360, which is the same place. And here we see those 30-degree reference angles again. Pi over 6 over here in the first quadrant, and 11 pi over 6 over here in the fourth quadrant. So here's the 180, and we go 30 down and 30 up. That's 180, 30 down, and 30 up to the 5 pi over 6 and the 7 pi over 6 from pi. 30 degrees from the negative x-axis. So if we go away from the 180, in quadrant 2 and quadrant 4, we get the 3 pi over 4. And in the third quadrant, 5 pi over 4. In the first quadrant, we get just the regular pi over 4. And in the fourth quadrant, we get 7 pi over 4. We're just taking it, instead of going around the circle, instead of going around the unit circle, I'm taking the unit circle and I'm unrolling it. And we're going from 0 to 360 or from 0 to 2 pi in a horizontal line. Moving away from the 180, moving out from the 180 again, we get the 120 and the 240, which is 2 pi over 3 and 4 pi over 3. Going past the 90 and 270, we get pi over 3 in the first quadrant and 5 pi over 3 in the fourth quadrant. Finally, on the y-axis, we've got 90 and 270. 90 is pi over 2. 270 is 3 pi over 2. We're just taking the unit circle and unrolling it. Originally, it was going to be unit circle roll-ups, and then the candy company came along and said, what if we made fruit roll-ups instead? Are fruit roll-ups still a thing? Where they like take a bunch of like partially dehydrated fruit and smash it down, and then they'll roll it out on cellophane, and you have to like roll it up, and like your hands are sticky for the rest of the day. Here's what we want to do today. We want to think about what we're trying to do is get our unit circle to go sideways. We want to think about what's happening with cosine and sine as we go around the unit circle. So underneath each of these values, I want to write the cosine of each of these angles. Remember the values that we had. This is just a unit circle, but instead of going around like we did on Thursday, we're just going to take the cosines, the x coordinates, and we're going to write them horizontally. So what I mean is that cosine of 0 is what? What was cosine of 0? What's the x coordinate at this point here? Cosine of 0 is 1. What happens? What is cosine of 90? Let's pick out the ones that are easy to remember. So the x coordinate here is 1. What's the x coordinate at 90 degrees? 0. What's the x coordinate at 180? -1. What's the x coordinate at 270? And the x coordinate at 360? It's back to 1. So here's what's going on in each of the 4 quadrants. In the first quadrant, cosine starts off at 1 and drops down to 0. So here's the first quadrant. Here's the second quadrant. And here's the third quadrant. And here's the fourth quadrant. So if we look at those cosine values, we start off at 1, down to 0, down to -1, back up to 0, back up to 1. Cosine starts at 1, drops to 0, down to -1, back to 0, up to 1. So if I was going to draw a graph of this, so the scale that I've got down here, vertically, I'm going from -1 to 1. Down here is -1. Up here is 1. Here is the middle. There's my theta axis. Here's my cosine axis. In between each of the midpoint, high point, midpoint, low point, midpoint, I have 3 dots. So it's like here, 30, 60, 90, 30, 60, 90, 30, 60, 90, 30, 60, 30, 60, 90. Missed it by 1. I divided each quadrant into 3s because I want 30, 60, 90 in each quadrant. Oh, I did sine. Heck. I'm gonna have to edit this out later. This is why I shouldn't have afternoon classes. Unfortunately, it's also why I shouldn't have morning classes. Let's try this again. So I'm going to split up my horizontal axis into 4 quadrants, and I'm going to divide each quadrant into 3s. So a 30, 60, 90. That's the first quadrant. So I've got 30, 60, 90, 30, 60, 90, 30, 60, 90, 30, 60, 90. And that'll get us all the way around. But I want cosine, so I'm going to start off at 1. Cosine of 30, 60, 90 is 0. Cosine of 120, 150, 180 is -1. Cosine of 210, 240, 270 is 0. Cosine of 300, 330, 360 is back up to 1. So we can see the x-coordinate as we go around the unit circle starts off at 1, drops down to 0, then down to -1, back up to 0, back up to 1. 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0. Everybody see it? 1, 0, -1, 0, 1, 0, -1, 0. You're getting very sleepy. Your eyelids are getting heavy. 1, 0, -1, 0. You're feeling all the tension from training from the top of your head down through the I'm just practicing my retirement plan, which is open an insomnia clinic. I'm not going to do anything different. I'm going to do exactly the same thing. I'm just going to have more comfortable chairs and use my soothing voice. So we see the graph. We can see what the graph is going to do. It's going to go down and then back up again. We see the graph going down and then back up again. See the graph going down and then back up again. But we want some more detail in this graph. We want some more detail in the graph. Remember, I marked each of these lines at 30-degree intervals. And I also cut my vertical axis at 1 and then 1/2. What angles have a cosine of 1/2? What angles have a cosine of 1/2? What's our reference angle if the cosine is 1/2? 60. So at the 60s, at all these 60s or the pi over 3s, those are the 4 angles that are going to have a cosine of 1/2. Cosine of 60 is 1/2. Cosine of 120 is -1/2 because we're in the second quadrant. Cosine of 240 is -1/2 because we're in the third quadrant. Cosine of 300 is back to +1/2 because we're in the fourth quadrant. These are the points that are 30 degrees away from 90 and 270. Notice the location of these points. Here's 90 and 270. 30 degrees away from that are the 60-degree reference angles, where the x-coordinate is equal to 1/2. So at cosine of 30, 60, 90, 120, so at 60 and 120, we're at 1/2. The other place we're going to see these 1/2 is 30 degrees on either side of the 270. At 240, 30 degrees before 270, and 300, 30 degrees after 270. This is giving us more shape to the graph. Instead of just down and then up like in a V shape, we're bending it a little bit. We're going to cross those halfway points, 30 degrees off every 30 degrees on either side of where we cross the theta axis. We hit our halfway points 30 degrees off of where we cross the theta axis. And cosine crosses the theta axis at 90 and 270. At pi over 2 and 3 pi over 2. This is where we get our 30 degrees before and after that. Pi over 6 radians before and after that. We're at 1/2. Pi over 3 radians. Did I say pi over 6 or pi over 3? That was like a whole minute ago. I can't remember that far back. Oh. "30 degrees before and after crossing the theta axis, we mark plus and minus 1/2. The reason that we're picking the plus and minus 1/2 is that that's easy to find. What is the decimal approximation of square root of 3 over 2? How much is that approximately? If by your silence you mean 0.8660, that's correct. 100% for everybody. 0.8660. How do we find 0.8660 here? Yeah, well, we don't. It's hard to find, right? Because I can find 1/2. I can split that in half and find a quarter, like a 0.75. That'd be okay. Maybe a 0.25. But now it's getting a little bit sketchy. So here's how we're going to draw this graph. Here's what we're going to do. We're just going to connect the halves through the middle with a line. It's not actually a line, but it's close to a line. Connect your halves through the middle. At the top and the bottom, the graph goes flat. So what we're going to do is draw little flats down at the bottom. Not big giant ones, just little tiny flats. Then we're going to connect the flat up to the line parts. And this will give us a nice graph. So we're going to smoothly bend the flat parts up to the line parts. Smoothly bend the flat parts down to the line parts. Smoothly bend the flat part. I can't do it from this side. This is the same direction. I need to turn the paper over and do it from the back. And this is how we produce a nice hand-drawn graph of cosine. And we're going to do the same thing for sine. Connect the halfways with lines. Even though they're not exactly lines, they're very close to being lines. Connect the halfways through with lines. Flat on top and bottom. Connect the flat to the line. Here's a graph of the x-coordinate going around the unit circle. Cosine of 0 is 1. Cosine of 60 is 1/2. Cosine of 90 is 0. Cosine of 120 is negative a half. Cosine of 180 is negative 1. Cosine of 240 is negative a half. Cosine of 270 is 0. Cosine of 300 is a half. Cosine of 360 is 1. Repeat the same thing in radians. Oh, I wasn't supposed to read that. I was actually supposed to do that, but I'm not going to. Where your sinusoidal graph crosses the theta axis, 30 degrees before and after that is where you hit 1/2. So we started off just going top, middle, bottom, middle, top. And then we gave it some more bend by identifying where the halfway points are. The halfway points are 1/3 of the way from the zeros. Any questions? How's everybody okay? I really just thought you all look like this. You're all mad because I didn't give the practice test back because I haven't finished grading. You're like, oh, dude, that's the best time to give it back to us. We can write more answers on it and then give it back to you. I also haven't posted the Canvas version of it. Let's take a break, come back and draw the graph of sine. Let's take a few minutes and draw the graph of sine. It's going to look very similar to the graph of cosine. It's going to be like turned 90 degrees. We're going to do the same thing. Sine of theta is the y-coordinate as we go around the unit circle. So let's track the easiest place to find. That's what's going on in between quadrants. So the y-coordinate at 0 degrees, so on the y-coordinate at 0 degrees is 0. So sine starts off at 0. Sine starts off at 0. Then in the first quadrant, the y-coordinate goes from 0 all the way up to 1. So in the first quadrant, sine, the y-coordinate goes from 0 up to 1. Here's the y-coordinate of 1, and that happens at 90. And then let's mark that on our horizontal graph as we unroll our unit circle. At 90, the y-coordinate is 1. Then if we keep following the circle around, our y-coordinate drops down to 0. And then our y-coordinate drops down to -1 at 270. And then back up to 0 at 360. So we can see that the sine graph starts in the middle, goes up, down, and then up again. So we get 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0, 1, 0, -1, 0. 1, 0, -1, 0. Going to be here a while because it goes on forever. So in here we see when we lay it out sideways, here in the first quadrant from 0 to 90, the sine, the y-coordinate, the sine goes from 0 up to 1. And then in the second quadrant, we go from 1 down to 0. But notice in the second quadrant, sine is positive, and we have positive values of sine. In the third quadrant, we get negative values of sine, and we're going from 0 down to -1. In the fourth quadrant, sine is still negative because the y-coordinate is still negative in the fourth quadrant, and the sine goes from -1 back up to 0. We want to get some kind of bend. We don't just want to draw a jagged line like this. We have better graphics now, so we're not just going to like connect these lines in a zigzag. The way that we're going to get bend is the same way we got it with cosine. We're going to mark out where things are 1/2. We're going to get 1/2 when we're 30 degrees before and after we cross the theta axis. Sine of 30 is a half. That's 30 degrees after we crossed the theta axis. Sine of 150 is a half. That's 30 degrees before we cross the theta axis. sine of 210 is negative 1/2, 30 degrees after we cross the theta axis. And sine of 330 is negative 1/2. That's 30 degrees before we cross the theta axis. So the next thing, once we get our top, middle, and bottom, we mark off where we got our halfway points, which will always be 1/3 of the way from 1/3 of the way either side of crossing the theta axis. We're going to connect our halfway points with a line through the theta axis. So we connect our halfway points with a line through the theta axis. It's not actually a line through the theta axis like that, but it's close to being a line. On this other side, we kind of have to like go up to up here. And then we kind of Mario warp onto the other side. At the top and bottom, we draw the graph flat. And then we just connect the flat part to the line part. So we come straight off this top part and then just kind of bend towards the line. Here's where we're headed. And we just create a bend that goes flat. Flat, and then we aim for the line. Mark the high and low points flat, and then aim for the line. The graph ends up being the same shape. The graph ends up having the same shape as the cosine graph, but it's just turned 90 degrees or just shifted 90 degrees over. Because we could think of the cosine starts off at 1, at 0. So if we take this graph and shift it over 90 degrees that way, or pi over 2 radians that way, we will get the same graph. So mark your high and low points. Mark the points at the top, middle, and bottom. Mark your plus and minus 1/2, 30 degrees before or after crossing the theta axis. That is the middle, before crossing the middle. That's where we put plus and minus 1/2. Connect the halves with a line. Which is close enough. Make your graph flat at the top and the bottom. Flat at top, not flat at pot. Make your graph flat at the top and the bottom, and then connect the flats to the line. And that gives us a nice sinusoidal graph, plus a cosine or a sine graph. Any questions? The 1/2 are the closest thing to the 0. Yes?
So you do this, you use the sine of it.
Yes.
So you would never do it.
With cosine of 60 was 1/2, so that's why I was off. That's why I was different for cosine. The 1/2 happen a third of the way through the quadrants. The 1/2 happen a third of the way through the quadrant. That's what we want to think about. The 1/2 happen a third of the way through the quadrant. How's that okay? You'll be graded on your artistic ability to draw sinusoidal graph. I just want you to put the points in the right spot. How's that okay? I did look super slow. Y'all look like this. Don't draw them like I do. Try to draw them symmetric. This one came out kind of dented. There we go. They look more symmetric if you make like sketchier lines. Also, when you draw them smaller, then it's harder to see the details. Get your top, middle, and bottom, get your halfway points a third of the way through the quadrant. Any questions? Comments? What we're trying to create with these graphs, we want to understand how these graphs work because we want to create models for things that go up and down. So like high tide and low tide, when are these things going to happen? If we can create a model, we can figure out when high tide is going to be and when low tide is going to be. If we can figure out what the frequency looks like, what the graph looks like for a sound, we can cancel it out by putting a sound with, get some frequency cancellation. I forgot what that's called. But like noise canceling headphones, listen to what's going on around you and then put sound through the speaker that cancels that sound out. Any questions? Don't at me in the comments. I'm not an audio engineer. I need you to get all the way off my back about that. Comments. Actually, there won't be because I turned comments off. Suck it, commenters. Any questions? Comments? Snide remarks. Okay, this is our next thing. What we need to do once we get these basic graphs down, the basic graph of sine and cosine, then we can start modifying the graphs of sine and cosine. We're going to modify the graphs of sine and cosine. We're going to stretch things up and down. We're going to stretch things side to side, and then we're going to shift things side to side, and we're going to shift things up and down. Those are the main things that we're going to do. Then we're going to try to understand why we're getting the effects that we get when we do those things. Any questions? Comments? Snide remarks? This is week 8, so we're almost halfway through this semester. All right, that's going to do it for today. I will see you all on Thursday. Everybody have a good 2 days, and thanks for playing.